So this is a maximization minimization problem that's based on revenue. So we need to make sure we know the revenue equation. So revenue is equal to the price. So we need expression for price times the number sold. Okay, so it says here the bus company has 3,000 passengers, so that's how many we sell at $35 each. So the price would be $35. So we're going to change this and make this a relationship. So they're going to change the price by $5 increments, and that means that they're going to affect the number of passengers, and they're going to lose passengers in groups of 150 for every $5. So to make this a revenue relationship, we need to have the price, and we need to have it in terms of some value of X. So the price, I'm going to start off with $35, but what am I doing to the price? Well, I'm going to increase the price by $5. So I'm going to increase it by groups of 5. And the X then represents the number of increases. Okay, so we do groups of 5, so it's going to be 5x. The passengers, we're going to start with 3,000, so that's our number sold. And with the passengers, we're going to lose groups of 150. So I'm going to do minus 150, but in groups of x. So for every x, we're going to increase by $5, decrease by 150 people. So this is going to be, then we've now got our equation. Now, to determine the best price, we want to, and to maximize revenue, we want to find the maximum value of r, or the vertex of this function. So there are a few different ways we can do this. So now we have the relationship. I'm going to find the vertex by, let's find the midpoint of the zeros. So the zeros of this function are going to be at x equals -7 from the first bracket, and then x is going to be positive. From here, we're going to end up, it's going to be 3,000 divided by 150, or positive 20. Okay, so those are going to be our x values. And then halfway between, to find the vertex, is going to be the average. Average of those two, so the vertex is going to be at 6.5. Okay, so x equals 6.5. If I want to calculate the revenue, I can just plug in that x into my equation. So when I plug in x into my equation, I'm going to calculate the r of x here. So maybe I'm just going to do it right here. I'm going to put 6.5 into the x value. And when I do that, I end up with 35 plus 5x. So 5x, 5 times 6.5. And then 3,000 minus 150 times 6.5 for x. And I can calculate my vertex, or my max revenue, based on that calculation. So I'm just going to type that in my calculator here. So 35 plus 5 times 6.5 times 3,000 minus 150 times 6.5. So that 6.5 represents the number of increases and decreases of $5 and 150 passengers, respectively. So I end up with not 195,000 $195,918.75. Okay, so that represents my maximum revenue when X is 6.5. Okay, now what the question actually is asking, so I haven't really answered the question. I didn't really need to do that. The question really is asking us to determine the best price. So I need price. I'm going to use that calculation there. So really to answer the question, I didn't need to calculate the maximum revenue. I just need to know the price. And for the price, I just plug into that price equation. I get 35 plus 5 times 6.5. So the best price, 35 times 6.5 gives me $32.50. So if I increase the price to $67.50, that's going to give us the max revenue. Okay, and that max revenue happens to be 195,900. Oh, there should be not a decimal point there, but $918.75. Okay, so we can solve by quadratic formula, and we can check our solutions on our graph. So although we can't graph, it's always a good idea to be doing this when you're doing problems. So if I have x, I'm going to solve for x here, so I'm going to end up with negative of negative 3 plus minus negative 3 squared minus 4 times a times c all over 2a. Okay, so simplify that out, 3 plus minus. This is going to be, we're going to add, so we're going to do 9 plus, looks like 40. So we're going to get square root 49. That's a perfect square, which means this is actually factorable. So our solution is 3 plus minus 7 all over 4. Okay, or in other words, we get 10 over 4 and negative 4 over 4. Okay, so that simplifies to 5 over 2, or 2.5, and negative 1. So we can check this by graphing this. So we can go to our graphing tool. Okay, and when we check this by graphing, what we should expect to see is we should expect to see the zeros matching where it crosses the x-axis. It should match the zeros of the equation. Okay, so when I graph this on my graphing tool, I end up with a graph that looks like this. It's going to cross at negative, looks like it's at negative 1. It's got a y-intercept at negative 5, and then it's going to cross here. That's going to be 2.5. Okay, so our graphs can confirm the solutions to the quadratic equations. Really, make sure we understand this idea that the solutions to the quadratic equation equal to 0 are going to be found along the x-axis.